Yeah. All right, so again, there's your bell work. I'll give you like 1 minute. Didn't take long. Do you know it or you don't?
But it's a line.
What is the line? We talked about that last class. And then y-intercept goes pretty far back. The blue line is the line that is graphed. So using the blue line in the graph, you should be able to just pick out what the y-intercept is.
I never say that was bad. Like Mr. Gill was the first scheme 12%. That's really.
What about Mr. Clean?
He's made
Mr. Clean.
Mr. Clean.
Is he?
Some like, you know, that. Stupid. I know she's a cheese. How much is that? Yeah, it's food.
She's okay.
You are too, because I know you're fat.
Interesting.
Let me go speaker.
Six. Oh, today is February 1st. New month. New birthday month. Oh, I gotta put a birthday sign. Bye from Danielle. You get a present from December. I haven't even done December.
What is the B value?
So you didn't get a present yet for your birthday. Oh, you did get one? I couldn't remember. I think you're the only one in this class. Yeah. What? Yeah. Yeah.
I'm sorry. What? He wasn't
I was trying to figure it out. I heard enough of it that I thought I could figure it out. Are you ready? You know what to do. Yeah. Like I didn't know. It's like you were asking me if you were ready. I was like, oh yeah, we're learning a lot. Actually, it's not a lot. All right, so we're starting. It's a new lesson, but we've actually already touched on it. So I don't think it'll be a real difficult day. So again, you should have plenty of phone time. So let me see playing on your phones. The usual, don't make me mad. You have a good day. So for this particular lesson, we're going to review quite a bit of stuff. And this is stuff that will help you a lot next year. You understand these, what again, are kind of like the beginning things we started with. It's not up there, but really quickly, what is an equation? We say an equation.
What is,
An equation. Any equation is really just this.
it makes them. Technically.
It's a rule that says whatever's on the right side equals whatever's on the left side. It could be all numbers. It could have a bunch of variables. It could have one variable. But whatever is on the left side equals whatever is on the right side. That's why we put the equal sign there. All right? That's the whole point of that is to say this side equals this side. Sometimes, because that is a rule that has to be true, that allows us to solve for a variable. Now, sometimes it doesn't allow us to solve for a variable, but it allows us to graph. So if we can't solve for a variable, so basically if there's two variables, then we can graph the line for the equation. But what does the line represent? So now getting to question number one. So when we graph an equation, what's that line represent? It's all of the answers. The reason we can't solve if there's two variables is because there's too many answers. You can't solve and just get one answer because there's too many answers. So what we do is we show all of the answers by making a graph. For whatever equation that came from, actually we can figure it out real quick and I'll show you. So it would be what? 4/3. So that equation is y equals 4/3 times x. So we'll talk about slope and y-intercept in just a second, but for now, just accept that that's that equation. I don't need to like try to do math to figure out point. Well, I might sometimes, but I could figure out some points on that just by looking at the line. The line's all the possible answers. If I pick a point that's pretty easy to see, like where it lands, like for example, that point right there, I can tell that's 3,4. I can tell this point is 0,0. I can tell this point -3, -4. So if I use any of those points, I'd be willing to bet it's going to make the left side equal the right side because they're on the line. It has to be a solution if it's on the line. So 0, 0 is pretty easy to test. Plug in 0 for y. 4/3 times 0. Sure enough, get it. Left side equal right side. We'll plug in. So 4 is my y, 3 is my x. So that's 3,4. We're kind of going back to needing to know how to put x and a y on a graph again. So your left and right number is your first number. So I go left to 3. I'm sorry, right to 3, my first number, up to 4, my second number. So remember, left and right to the first number, up and down. Quick review of that. So if I now plug in 4 for y equals 3 is my x, so 4/3 times, I have to change it to 3/1. I'm going to do the short version of it. Those go away. They divide out or multiply out to be just 1. So I get 4 equals 4. Left side equals the right side. Any point on a line will make the equation, make the left side of the equation equal the right side. And then lastly, so what did we say a y-intercept is? So if I have that line, how do you find the y-intercept? It is not this long thing. Everybody wants to say that's the y-intercept. That's the y-axis, not the y-intercept. So if you didn't know that, if you were thinking the y-axis is the y-intercept, no. The x-axis is a number line. The y-axis is a number line. Big, long number line, not a point. Y-intercept is a point. How do we find that point? Where you talk? How do we find that point? It's a visual thing. There's no math required. For this one, there's no math required. Somebody said something. Say it again. Not. I mean, you're looking at the graph, so I mean, I guess you could say you go left to right and you're looking for. There's just one specific thing you're looking for. If you don't, well, clearly you don't remember it. Make sure you write this down. It's like bare minimum you're going to need to be able to get through algebra next year. It will come. Y-intercept will be used a lot, both when you're graphing, sometimes just when you're using equations in that same format. I'll tell you one thing. You don't know this. This is the equation that we're going to use today, the format. The y-intercept is the b variable. So variable b stands for y-intercept. So you're going to want to write that down. M is the slope. B is the y-intercept. So you can kind of start taking your notes while you can't see how to spell intercept. It's also up there. B is the y-intercept. So that's what those variables stand for. X and Y are just solutions. That would just be like our ordered pairs, like 0, 0. So this X and this Y have an infinite number of numbers. Like, so you can't really put a number to those, like not a permanent number. It'll change. Sometimes like one X and Y would be 3 and 4. One X and Y would be 0, 0. One X and Y would be -3, -4. These numbers are permanent. Slope is always going to be the same number. Y-intercept is always going to be the same number. They don't change. So with that in mind, how do we find the y-intercept from a graph? Said you look at where the line does something. Kind of has to do sort of with the word intercept. Well, b is the variable, and I want the number now. You can get the number for me from this graph. Tired, scared. All right, so you need to write this down. Wherever the line that is graphed, again, we're not talking about the grid lines, we're not talking about the number lines, wherever the line that is graphed crosses the y-axis, that's the y-intercept. So your line intercepts, which means like connects or meets, it intercepts with the y-axis. So if that helps you remember, if you can kind of use that definition of intercept, to connect or to meet. Wherever your line, in this case, when I say your line, I'm talking about the blue line, that's the line that's graphed. Wherever that line connects or meets the y-axis, that is the y-intercept. Now, we can write it two different ways. We could write it as a point, like an ordered pair, 0, 0. So that's where the y-intercept is. But in an equation, we're not going to put 0, 0 somehow into an equation in one spot. So we just use the y value there. So in this case, so b is 0. We take the y value. So in this case, b equals 0. If it would have met somewhere up here, like it would have gone through here, we would have said b is 3. If it would have gone through here, b would have been 6. If it went through down here, b would have been -2. So it's just no math. That's one you've got to be able to get. Remember, we did a version of this where we pulled them out. Is anybody still writing that? We did a version of this where we pulled it out from equations. And I think we've done it from a graph also. Oh boy, it's probably way, way back. So hold on. Oh, we never really did that. Yeah, we can. Oh, hold on. I got a lot of stuff. Oh, I know we're not actually going to. A lot of slides. Slow. We'll talk about that again next class. Maybe it's not even this. There, fine. Oh, yeah. Remember we did a sheet like this where I gave you I think this was actually on one of your quizzes. I gave you equations. So you had to pull out the b value from an equation. Now we're pulling it from a graph. But it'll relate, like whatever the b number you choose is from the equation, this would be the point where your line goes through the graph. So if your b value is -8, after you graphed it, your line should be going through the y-axis at -8. So you got to make sure they match up. That's one way you can match up like multiple choice questions. You may not know how to graph these equations, but if you can match pieces of them up, that's like a little kind of shortcut cheat sheet way to do okay on multiple choice tests. A lot of your tests next year, from what I've seen, have some multiple choice stuff in it, not to mention your EOC is all multiple choice. So learning how to take those educated guesses, I hate the word guess, but educated guess, you have to do that sometimes. If you say, well, I know that my line, I don't know how to graph that. I don't remember the whole process to graph, but I know that's the y-intercept. So I know my line has to go through -8. That might eliminate some of the answers right there. There might be lines that go through +8. So you could eliminate those immediately. There might only be one line that goes through -8. Sometimes they do make it pretty easy. And if you just know one piece of the graphing process, then you can figure out from a multiple choice how it works. Again, so here you would have going through 0 because there's no number. The y-intercept is always the number that's by itself. So that's y-intercept, y-intercept. The y-intercept, if there's no number, so here we have only something with an x, that means it's the 0. So that's the one we just created. We just created one where it went through 0. Here's the y-intercept. Doesn't matter where it is. Like, I don't know why. I think I have a better version of this in one of the slides, so I'm not going to try to find it. It's not always the second thing. Don't think it's the second thing. It's the one without the x. I could rewrite any of these equations and say y equals 1, subtract 2x. Well, that doesn't mean -2 all of a sudden becomes the y-intercept, because now it's second. The y-intercept is always the one that is just the number, not with the x. So here, there's no x at all, so that is a y-intercept. It's a number by itself. And you have to have y all by itself. That's the other key thing. If y is not by itself, if there's anything else on this side with the y, then you don't even have a y-intercept or slope. Just kind of keep that in mind. We'll get to some where that's true later. But don't forget, we're doing a very specific type of equation. It's called slope-intercept form. Y is going to be all by itself. That's what makes the other side have a slope and a y-intercept. And I know you didn't get all of that, but trust me, we're going to be doing it for a while. So, all right. So now I'm just going to do this the faster way instead of trying to look through all of those screens again. All right. So any questions about what a line is, how to find a y-intercept on a graph? So what we're doing today is we're going to do some solving. So there is going to be a little bit of math on this today, but I don't think it's anything crazy. If I give you a graph like that, and I say, where's the y-intercept? Visually, I'm hoping you can at least point to it, but I'm pretty sure you're not going to be able to tell me what the y-intercept is. Why is that? Well, let's talk about, so where is it? Let's just repeat it, just so we repeat it again. Where's the y-intercept? How do we find it visually? So Josiah, I'm going to call on you because you got your earbuds in and just need to make sure that you're following along. So wherever my line that is graphed crosses the y-axis, I'm going to zoom in for it. Because on this one, we got a problem, don't we? I can find where it crosses the y. Ooh, that one. I can find where it crosses. That's not difficult at all. I know it's higher than 0 because if it crossed here, it'd be 0. I know it's lower than 1, but I have no idea what number that is. I could guess. I could make a pretty good guess. I could say, well, pretty close to halfway, maybe a little below halfway. We're not going anywhere yet. That's what we're going to try to do. It will be a decimal. That's exactly what it will be. But do you know like what decimal? There's an infinite number of decimals. Maybe. Could be 0.4. Could be 0.49. Could be 0.4999999. So there is nowhere. Yeah. So there is no way, 0 chance of knowing what number that is exactly. Now, again, if you don't follow what we're about to do today, this is where you make an educated guess. Look at the graph and say, well, I know it's got to be less than 1. I would say pretty confidently it's below the halfway point. So I don't think it's exactly halfway. So I would say it's got to be between like 0.2 and certainly between 0.2 and 0.5, but maybe even between 0.2 and 0.4. So look at your multiple choice. If there's only one graph that says plus 0.3, and all the other graphs have something that makes no sense, and that's going to be your equation. Like that's at the end of the equation where the b value would be. I'm telling you, this is how a lot of you are going to pass your algebra graduation requirement, your testing requirement. It's not going to be because you knew how to do every single problem on there. It's going to be because you took the test seriously and you remembered enough to kind of make a lot of really good best guesses. I know a lot of the kids, my first year I taught here, I taught Algebra 1A, taught it every year. A lot of those kids have not met their algebra requirement. They're still taking that test. And they may walk, did I have that conversation with you? Don't think just because a kid walks across the stage that they've met their testing requirements. If you're like, well, I know that kid, I know I'm better at math than he is. Well, he may not have passed. He may be walking across the stage, but he may not have passed. So don't think that you're just going to cruise into passing those tests. A lot of them will walk across and not get a diploma. They'll still be working to pass their requirements, even after their senior year. So again, we're going to learn how to calculate it out today, but if you really struggle with it, just you got to remember, because this is definitely something, the y-intercept is Again, I don't know what's on the EOC, but I can't imagine that's not something that pops up several different times in different ways. So here's what we're learning today. There is a way, if I give you the information you need, you can calculate out what this is. So I'm going to kind of get you started with an easier one. I'm going to do most of the work. So you don't need to have the line. I'll tell you what to write in a second. So for now, just follow along. I have an equation like this, right? I want to solve for a variance. I'm so excited. Touch. You guys get this, correct? Say it a lot, but I've never really made it a big deal. In what situation can we solve for a variable? Or if you know when we can't solve for a variable, that's too. When can I solve for a variable and come up with an answer? Or when can I not? Like, what are situations where I cannot? There's something I said, I've never ever made you write it down. Never. Say it a lot. Let me ask you this. Can I solve and come up with what B equals right now? Number. I don't have any numbers, right? How would I possibly do that? So what would I need in order to be able to solve?
I'm gonna just done one variable.
Oh, thank you so much. One variable, one equation. That's what I need. I somehow need to replace, if I know I'm solving for B, so I already know that's the variable. That's what I can only have B in this equation if I want to solve for B. I somehow have to figure out these three things. Now, I can't do any math to figure those out. Well, I mean, I guess I kind of sort of can, but somehow from the graph, I need to get that information for those three things, or they need to give it to me. Like in a problem, sometimes they'll just give you this. They'll just say your slope is this. Well, they won't tell you what. Well, yeah, they kind of will tell you this. That's what you're going to do today. They're just going to give it to you today. So what is the M we said? So that's slope. Does anybody, now again, like you already adjusted, if anybody can give me the answer to this, I'll be like, you know what? I'm gonna call my mom and like, if anybody gets this answer, I'll be like, Mom, I'm so excited about my God teaching and it's the right decision. I mean, I might call her anyway, because I haven't talked to her. So, M, what is the formula for slope? Actually, I'll take it. We learned one that we use more for graphing, and then we used a second one. What did we use the second one for? Oh, rate of change. We used the second one for rate of change. So we did it more with a table. It's slope and rate of change are the same thing, if that helps. What is a formula for slope? Appreciate you guys looking it up so that if you want me to call my mom and see how she's doing.
Yeah,
I'm gonna tell if I call my mom, if you guys find it, I'll be like, Mom, they never looked anything up, but they really wanted me to call you. So they actually.
I'll put her on speak.
Well, I could do it. Should I do it from class? I'll do it from class. Want to do it? I'll just do that one. They're an hour behind in the central.
Is it?
I mean, there's no like points off for being wrong. So guess everything. Just throw everything.
Why?
Oh, that's the tougher one, but.
Is it that one?
Yeah, that's one of them. What is it?
Minus I.
By one. That's right.
Oh, next one.
Oh, I'm calling my mom tonight. I'm gonna tell her that you guys that was the deal. She'll be like, so you were gonna call me if they didn't get it? Like, have you seen that commercial? It's Wendy's, I think. Probably don't see commercials. We don't want to.
I'm not.
There's this thing. They have this new breakfast product out or something, and the guy's sitting there with his mom, and he's like, these are the best things that anybody ever makes, and she's like, really? And he finally realizes he's basically saying they're better than hers, like what she makes. And it's kind of that same concept of, whoops, I just put my foot in my mouth. I do that a lot, actually. So the other one, anybody remember the other one? There's a much simpler one that we learned. Rise over run. Rise over run is the other one. So either way, we can figure out what the slope is from the graph. I'm going to use the rise over run version You don't have to worry about writing this down. You don't have to do this part today. I'm going through a little bit longer one, mainly because I'm recording. So if I take 2 points, and they need to be points where I'm going right through line. So this is pretty close. Even if it wasn't absolutely perfect, I think it is pretty good. So those two, oh, ignore this one. I know that this point and this point are pretty much right on like an X and a Y value. This X and Y value is -1, -1. -1. I don't know what I did there. -1. Oh, and then it messed up. Went back to the skinny version. So -1, -1. This is 2, 3. So if I know those, I could do the whole Y2, Y1. I could label them X1, Y1, X2, Y2. I'm going to do rise over run. I'm going to say 1, 2, 3, 1, 2, 3, 4. Now I just say, okay, well, what is my run number? Run number is +3 because I went right. Rise number is 4. Huh, it's got the, must be the same graph I used for the bell work. Yeah, it is. So I have the same slope. In the last problem, I had 4/3. I have 4/3. So I know one more piece. So hey, we got rid of one variable. We got to get it down to just the b variable. So somehow we've got to get an x and a y. What do you think I can do to get an x and y? Slope I figured out. So for this equation, I'll give you a hint. What are x and y in this equation? Like if we had the slope, what would x and y be? I'm sorry, if we had the b value already. Like let's say we had this. Y equals 2x plus 1. So let's say we had that, and all we had was x and y. What are x and y representing? And if you don't get that, this would be an answer. We make the left side equal the right side. X and y is an answer. Or, and remember, there's an infinite number of them. So every x and y represents an answer to the equation. So if we did a word problem and I said, I'm going to the store and I'm going to buy, and I'll just use one item, I'm going to buy honey buns. And I want to know how much I spend. Well, the amount I spend is dependent on how many honey buns, right? So a combination of those two things is an answer. 4 honey, and let's say honey buns are $2 to make my math. 4 honey buns, so that's an X, is $8. So that's one answer to the equation. Well, 1 honey bun would be $2. So that's an answer to the equation. So the X and the Y are the answers. So these are answers. So how can I find an answer for that when I don't even have the B value? What's a line? Don't I have all the possible answers I could ever need on the line right there? I have every X and Y value that exists, basically. Just pick one from the line. If you need to replace X and Y in an equation to solve for B, and I've actually already given you two, you don't even really have to pick it. This is what they do in the problems today. They don't give you a line. They give you the X and the Y values. They give you a point. So they'll give you, like they'll say, the line goes through point -1, -1. Or the line goes through 2, 3. That's your X and your Y value. That is a point that would be on the line. It's a solution. It's what you're going to plug back in. You can do either of them, and you'll see we'll actually do both of them, and I'll show you get the same answer. So I'm going to do 2 and 3 first. So let's plug in. So here's what you have to be able to do. This is now the algebra part, like just purely solving. I'm going to plug in 2 and 3 for Y. So 3 is there. 4/3, X is 2. So the math is a little trickier than you'll have to do today. Your math comes out easy today. Now I have one variable, one equation, I can solve it. So if I go through, this becomes 3 equals, whoa, sensitive. 3 equals 8/3 plus B. How do I solve for B with that? Just don't freak out because it's got a fraction. I want B all by itself. What do I need to do? Not divide, because that would be if something's with the B. Like if it's right next to the variable, that means you're multiplying, so you would do the opposite. We're adding, right? We're saying B plus 8/3. So what's the opposite of adding 8/3? You subtract. Don't freak out because it's a fraction. For some reason, you guys forget the steps. Like if that would have just been a number there, you would all said subtract. Because it's a fraction, all of a sudden people are like, oh, I don't know what to do. Just, it's a number. So if we would have subtracted 2, then we would subtract 8/3. Same, the process doesn't change just because it's a fraction. Now the math changes. So this is 3 subtract 8/3. So I'm going to do the math for you. You'll have a calculator moving forward, so math should not be an issue at all. So we get B equals, and I'm going to write it in a decimal. It's 1/3. B equals 0.333333. What did we say our estimate was? Between, we said like maybe between 0.2 and 0.4, right? Well, that's perfect because that falls right in between our. So that's the process. I want you guys, now the math will be a little difficult, but at least plug it in. Now let's test this point, because again, we should always get the same value. Any X and Y value that's a solution, which this is also a solution, should always give us the same answer. So at least, if you can't do the math with the negative ones and the fractions, at least plug in what you think you would do to solve for B, but using that point on the graph. At least plug it in, like how we're following the concept. And then we'll do the math together, and then after that, I'll put up what you're going to practice. I didn't print anything out. It's not that many problems. So here I'm going to erase this. I guess I could leave it up, just show you what I did. So you're solving for B. I want you to create the equation. So you should only have one variable. B should be the only variable. You're plugging in values for X and Y. The 4/3 doesn't change. That is the slope. The slope does not change. That will always be the slope. The X and the Y is what can change because you have an infinite number of X and Y values that are answers. Apparently, we're being. So if you have a snack, since Kaylee's decided that we can do whatever we want to. Luckily, you guys have answered my questions, so I just need you when you do that. So if you want to eat something, if you have a snack, I unfortunately do not have. I'm out of granola bars, so I need to go to Sam's. Super starving. I don't even know what I have. I might have some of those green Nature Valley bars that are absolutely starving, but not many of those. Nobody tends to like it. All right, so I'm just going to do a show of hands. Just be honest with me if you don't, because I guarantee you have to laugh. If you think you knew what to do, even if you're like not positive you got it right, if you think like, I think I did it right, I want you to raise your hand. Nobody has any idea what to do. I felt like you guys are getting it. That's why I asked. All right, so let's talk about it. So again, I want to solve for the y-intercept. To solve, I need one variable, one equation. Right now, so I'm going to get rid of all this red. Right now, I have 3 variables, B, X, Y. I can't solve for B if I've got 2 other variables. So I need to find a value of X and Y that I can plug in so that I then just have the variable B. So what I did before, this line is a whole bunch of X and Y values. Every point on that line is an X and Y value. And every one of those values is an answer to the equation. So I can pick any value on this line for my X and Y. I picked 2, 3 earlier. Just pick that one because it was, to me, they're both positive numbers. I know it's a solution because it's on the line. It has to be on the line, something that I picked. Or they have to say it's on the line. Sometimes in the problems, like this is the way it'll be today, they'll say the line goes through 0.2, 3. So if they're saying the line goes through it, that means it's on the line. But somehow you have to pick a point on the line, either visually if they give you a graph, or they'll tell you a lot of times the line goes through the point, whatever. So I plugged in this X and this Y for my X and my Y here, because that's a solution. Like we said, a line is all the solutions. Well, if it's a solution, then I can put it into this equation because the line matches the equation. If it's a solution because it's on the line, then it's a solution for the equation. So we got to make that connection. When I say it's every possible answer, there are answers to this. So now when I plugged it in, Y was 3. That's what the Y value was that I used over there in the upper right. 4/3. And then times my X value was the 2. I'm not going to go through and solve it out because, again, I'm just trying to make sure we understand how I'm plugging stuff in first. The math's easier in the practice one, so we're going to move those in a second. So that's how I plugged in, because I want to solve for B. I don't know what that number is, so I want to mathematically solve for it. I can't visually tell. I can visually sort of guess, but I want to solve out. So if I want to solve for this, then I have to replace all of this stuff. I replaced the slope by figuring the slope out. Today, they just tell you the slope, so you won't have to figure any of that out. They're just going to tell you today, they're going to tell you the slope, and they're going to tell you the X and Y to use. So it's actually a lot easier today than what we're doing. But I still want you to try to understand where all of it's coming from. So then, if I only have one variable, I solved all the way down, and I got B equals 1/3, which is the same thing as 0.3. So that means the y-intercept is 0.3333, or 1/3, which makes sense looking at the graph. That's where 1/3. So now, I'm just going to ask you, and if not, I'll do one more for you. Then we got to move on to the other ones. If I now just want to confirm my math, so I've already solved it out and I already got what the y-intercept. But I should get the same y-intercept because this line only has one equation. Can't have different equations. So if I would have used a different point, like if I would have used this point instead of that 2, 3, I better still get the same value of B. There's only one value of B. There's only one value of M. There's only one slope. I better get the same thing no matter which X and Y I use. So I'm going to now use this point. What do I write? Kristen, what do I write first? If you don't know, just say you don't know. Ray, what do I write? Still no idea? Kaylee, what do I write? So I'm doing the same thing I just did. I'm just using this X and Y. I'm replacing X and Y, well, Y and X, with this X and Y now instead of the other one. I could have picked any point on the line because they're all solutions. Right? So any point on the line can replace your X and your Y values. Obviously, you want to pick the easiest one to use. That's why I did 2, 3 first, because they're both positive as opposed to -1, -1. So really quickly, -1. Oh, I didn't mean to do that. I'll do the math for you. We better get 1/3. Who thinks we're going to get 1/3? So -1 times 4/3. I'm just going to kind of make that -4/3. If you didn't follow the math, don't worry about it. Plus B, well, if I want to get rid of this, I have to add 4/3, so that's plus 4/3. Sure enough, -1 plus 4/3 is 1/3. So I got the same answer. And you better get the same answer. So I got the same exact answer. You get all, there's no decimals or fractions today. There's only 4 problems. Do we need to tear? Yeah, we need to tear pages out today. So why don't we do that real quick? What are your pages? Tear out page 209 through 228. Start over there. When you're done tearing them out, just put them underneath your desks. It's up on the board right here. So once you get books, I'll say it again, but like otherwise I have to say it like 10 times. For now, just grab a book. Oh yeah, and don't put them back where you got them from because then the next group will, well, actually, it's not the next group. Just put them under your chair once you torn the pages out. All right. Are you guys seeing the pages?
Yes, I'm not seeing any of the pages.
So you did see them in this.
That means you
I
got
don't know if they're putting them back. I'm almost not there. I don't know if they were putting the bags on. Let's before we. 208 through 2. Let me just make sure that's the right pages. Hold on, let me make sure that. 208. It's in these. They're in here. I said they weren't in here. 209 through 228. You're not looking at this, you're looking at this. 209 through 228. They were in this book. Whoever gave me this one. Although it does look like, yeah, this one somebody did mess up and then they started over, which drives me crazy. If you mess up, don't get a new book. I don't have enough books for you to mess up and then just grab another book. Yeah, they messed up a couple of times. Excellent.
Good day.
Coming out today.
Of course.
Are you having fun out there?
Yes, of course.
Yes. Did you talk to Coach Gales?
What is this?
We got to figure out what's going on with track. We got a lot of girls that they want. So, and he's said that, you know, when we're in season, but never know how that works. He's gonna, I'm sure, try to pull you guys over to his practice. So we got to talk to him and find out.
Yeah.
We're gonna let our flag girls do track also. We got to come all kinds of work. We need you guys to our flag. Push up. Surely have done push up there about that. No. I know Katana's done push ups. What, didn't you use these new push ups one day? No.
How is no?
Oh yeah, you did do them one day. I remember. I thought we had one day where a bunch of people were using. I'm apparently incorrect. All right, so the book, just the only real reason you're carrying that out, I did the lesson for the most part on this. If you want to walk through it and do the examples, it's practice, you can. I'm going to give you some practice problems up here, like I said, that come out to be more like so here you go. Write these down. This is 4 example problems you can do. So M is the slope. So I've already given you the slope. So remember, this is your process. Let me zoom out. That would be easier. So if this, so again, I want to find the y-intercept for this particular line. There's a line that would go through 3, -3. So I'm going to kind of show you where that would be. 3, -3 would be there. It has a slope of positive. You don't have to graph anything. I'm just showing you visually how it'll look, so you kind of know if you get the right answer. So the slope would be 3 or really 3 over 1. So that would mean I'd go over 1 up 3, over 1 up 3, over 1 up 3. So if I want to continue that, I would look something like this. So this line is really steep. So it's not perfect, but the y-intercept, it looks like, is going to be like some pretty big negative number. Like this is -10, so -11, -12, -13, somewhere in that range. So visually, I now know about what I should get. So what you need to do is take this equation, and you're going to have to figure out what goes in these 3 things. And that will leave you just the variable b, and you should be able to solve that. And the math on these isn't nearly as bad. There's no fractions or anything like that, I don't believe. So I want you to try to figure it out first. In a minute, I'm going to do attendance, and I'll start walking around and helping. But at the very least, you better have all this copied down, every problem, leave yourself some room to work it out. You can go ahead and write this equation next to every problem. You should be able to plug something in from what I've given you. So that's 4 different problems. So you'll come up with an equation for this. Problem 1, 2, 3, 4. If you have 0 idea what to do, you can write this equation next to every problem and leave yourself some room. And when I walk around, we'll start doing pieces of it together. But I'm hoping you can plug all of these in. The solving may be a little more difficult, but if you can't plug anything at all in, then probably weren't paying attention. Probably zoned out. I'll freeze that while I do attendance. Oh, and now I will stop the recording. There we go.